Question 7. So question 7, you know that 20% of the shirts come from A, 30% come from B, and 50% come from C. Add together is 100%. This means that it's completely exhaustive and you actually need that later. So out of these shirts, for A, 3% of them are flawed, 5% from B are flawed, and 2% from C are flawed. So the question gives you that 15 shirts are ordered and they come from the same factory, 2 are flawed. And the question wants you to find what's the probability that it came from C, given that you find 2 flawed shirts. So this is what you need to find. So we named our events first. So A, B, and C means come from A, B, and C respectively. So this is quite clear. Then X is, we name it the number of flawed shirts that out of 15. So within 15 shirts, what's the chance of you having X flawed shirts? For example, 2 flawed shirts. So you can see that X is actually binomial 15 and P. So this P, it depends on this, whether it come from A, B, or C. So you can see because they have different values. So it is written in this way. So if it comes from A, then X will be binomial 15 and 0.03. If it comes from B, 0.05, C, 0.02. Okay. Then there's also this information that probability A equals to 0.2, B equals 0.3, and 0.5. This is what is the same as this, but I write it down in a different form. Okay, so what you need to find is this, is actually this. So sorry, this. So I write it down mathematically, which is this. So I apply the Bayes theorem. This is what is in your formula sheet. So you write this. And then from this, I change the probability X equals to 2 into this. And from there I change it into this. So as you can see, the numerator is the same, so it's quite straightforward. But how I get the denominator is based on this reasoning. So this is your universal set. This is all shirts. So this is your universal set. So it can come from A, B, or C. Then you know that A, B, and C, they add together is 100%. So that means all the shirts either come from A, B, or C. So let's say I divide it like that. So this is A, this is B, and this is C, because this is 20%, 30%, 50%. Okay, so you have an event. This event is probability X equals to 2. So this is probability X equals to 2. So this is your event X equals to 2. So how to find this probability X equals to 2, right? As you can see, it's actually this area plus this area plus this area. So what is this area? So this area, right, is actually equals to probability of X equals to 2 intersect A. Then the second area is plus this area. The center area is probability X equals to 2 intersect B. And the last one is probability X equals to 2 intersect C. So you see, probably X equals to 2, the whole area, right? You can chop it up into this tree. So that's how I get this one. And then how I get from here to here is just by the definition of conditional probability. So this is your conditional probability rule. So that's how I get from here to here. Okay. Okay, so once we have this already, right, we just need to find every individual component of it. So you just need to find this, and this. Okay. So as you can see, right, we already have all of this. Y comes from here, right? So we have all these numbers. So we just need to find all those which are marked with 1, like, which is we find below. So because X given A, B, and C, right, they are binomially distributed. So you just use the binomial formula. So probability x equals to given C equals to n choose x, which is 15 choose 2, times probability p is to the power of x. So p is 0.02, is to the power of x is 2. Then 1 minus p, n minus x. So 15 minus 2. Then you get this number. So because I use a lot of decimal because I just want to get the perfect answer. But you can round off in between the steps, but it should not affect your answer that much. Okay, so you do the same for B and A. You get this. So you have all the numbers that's required to find the final answer. You just plug them all in according to this, which is this one. You just put all the numbers in, then you should get the final answer. Okay, that's the end of question 7.